In this section, we are going to be solving systems with 3 variables this time. So this might be the first time you're doing this. Instead of just x and y, we're going to add in a third variable, x, y, z. So that answer is going to satisfy all 3 equations at the same time. Okay, so let's get at it. I'm not going to read this page to you, but you have it as a resource in your notes packet. If you want to, you can pause right now and review it. So for the purpose of this video, I'm going to label each one of these equations A, B, and C, and I'm going to color code them. You don't obviously have to do that when you're working. So what we're doing when we're trying to solve these is you're trying to eliminate one of the variables right off the bat. So you have to come up with a plan and decide which variable is the easiest to eliminate. And I think it's going to be Z, because I could combine equations A and B pretty easily, multiply A by 2, and you'd have the Z coefficients would be opposite. And then maybe I'll combine B and C to eliminate the Z's as well, because those would be easy to combine and eliminate the Z. So first thing I'm going to do is copy down the A and the B. I'm going to go ahead and multiply this red one by 2 so that the Z coefficients will be opposites. Okay, so now the Z coefficients are opposite, so we're going to go ahead and combine these. Okay, so I got rid of Z successfully. So now what we're going to do, we just did A and B, so now we're going to combine B and C, okay, to do the exact same thing. So you're going to recopy down B and C. Okay, so I have B and C copied down, and I need to multiply this top one by 3 this time to get the Z coefficients to match. Okay, now they match, so we're going to go ahead and we're going to add this. We've got 9x minus 14y. The Z's will go away. And there we go. So now what we have here, ooh, this is a little ugly. We've got these two that there's no Z. So we're going to have to combine these and solve for either X or Y first. Okay, so we're going to recopy those over here. Oh, this is a little ugly. So let's see here. Let's go ahead and maybe eliminate. I'm going to eliminate the y's. So I'm going to multiply this top one. I'm going to try to make this a positive 14. So we're going to multiply this equation by negative 14. Okay, let's do that. This looks really bad, but it's not as bad as it seems. So when we go ahead and add, I get negative 47x. These will cancel. This is going to be 94. Oh, if you divide both sides by negative 47, you get negative 2. And then we're going to go back into maybe this equation here and go ahead and solve for y. So we have 4 times negative 2 minus y is equal to negative 5. And we go ahead and solve that. Negative 8 minus y is negative 5. So I'm going to move the y over here, add 5, negative 3. Okay, so we have x and y. So now the only one we need is we need z. So to do that, we go back to one of the original equations. You can pick whichever one you want. I'm going to go ahead, I don't know, I'm going to pick A. Seems like it's the least amount of work. So I'm going to go ahead and copy that down. I'm going to go ahead and plug those values in. Negative 2 minus 3 minus c is negative 9. So we end up with, I'm going to move the z over here, and I'm going to add the 9 to the other side. And z is equal to 4. Okay, so the steps were elimination to get rid of one of the variables, solve for the x and y, right? We got rid of the z's, we solved for x and y. Once we have those, we go back to an original equation and solve for the remaining variable. We're going to do the same thing here with example number 2. I'll give you a plan and then I'll let you try it on your own, okay? I look here and I think the easiest is going to be, again, getting rid of the z's because they can all be turned into 6s if we wanted to fairly easily. So combine A and B first, and then maybe combine B and C, and then go from there. And I will do it. You can pause now and check your work against mine. Did you get what I got? When I went and combined the first 2 equations I picked, I got 0 equals 47. The variables went away. This is a false statement. So this is a no solution system. Okay. All right, let's take a look at the next one. All right, we look at these 3 equations. I think we're going to go ahead and work with the z's again. So let's start with A and B. Go ahead and add those. 2x plus 2y is equal to 8. And then let's go ahead and add B and C. Add those together. Okay. Now we're going to take these 2 equations. So I think I need this top one to be multiplied by 2. And I get 4x plus 4y equals 16. Oh, and the bottom equation is 4x plus 4y equals 16. They are the exact same equation. So if I subtracted, I'd end up with 0 equals 0, which is a true statement, and all the variables are gone. So this is infinite solutions. So those special cases also can happen with the 3 variable systems.